Hello, I'm Papia. In this problem, we have this given equation. We have to find dy dx using implicit differentiation. So we have to compute dy dx. Now notice that we're going to do implicit differentiation. So the first thing you should notice is that we have to evaluate ddx, and that we have to do on both sides of the equation. So the very first step is apply ddx to both sides of the equation, which means we will have ddx of x square, ddx of the next term, but you know that 3 is constant, you can pull it outside. So negative 3 ddx of natural log of y plus ddx of y square equal to, don't forget to also apply ddx on the right hand side. So ddx of 10. All right, now check that every term that you are taking the derivative of, if the variables are same or different. So for the first one, you are doing ddx of x square. Same variables, so you can directly apply the power rule, and the derivative is 2x. Okay, so the next term, you have negative 3 times. Note right away that the variables are different here. You're taking ddx of natural log of y. Okay, since they're different variables, you have to apply chain rule. So consider ln is the outer function and y is the inner. So you know chain rule, you have to go from out to in. So you take the derivative of the outside function first. So what is the derivative of natural log? 1 over whatever expression it has. In this case, it's y. So it's 1 over y. But you cannot stop there. You have to go further, go to the inner function, which is y, and also take the derivative of y. Okay, now it's complete. Third term, notice same situation. We have y and you're taking derivative with respect to x. Different variables, therefore you have to apply chain rule again. Okay, so first this is y square, so you do power rule first, which is 2 times y, but then don't stop, go one more step, you have to also take the derivative of the inner function, which is y. So you will have another piece ddx of y. Right hand side is just a constant you're taking the derivative of, and you know the derivative is 0. All right, so we have evaluated all the derivatives. Now don't forget, our goal is to compute dy dx. So let's see what we have. We have 2x minus 3 over y. Now what is ddx of y? Dy dx. So that's where we have a term with dy dx. Third term, we have 2y times, again, what is ddx of y? Just dy dx. Right hand side is 0. Okay, so what we have to do is, you look at all the terms on the left, keep those terms on the left side that has dy dx, and the ones that don't have dy dx, bring them to the right side. So if you notice, the second term and the third term, both of them we have dy dx. So keep them on the left hand side. So you have negative 3y dy dx plus 2y dy dx. And then the first term doesn't have dy dx, so you can bring it to the right hand side as negative 2x. Okay, now these two terms, we have a common factor of dy dx, so we can pull it out. And then we will have from the first term, what is left? Negative 3 over y, second term plus 2y. The whole thing is equal to negative 2x. So we can figure out dy dx equals, you just have to divide both sides by this expression. So then dy dx will be equal to negative 2x divided by this entire expression, negative 3 over y plus 2y. Okay, so you have your derivative here. If you want, you can simplify a little bit. So see, in the denominator you have a fraction. So let's make it into one fraction. So what we can do is we can add these two terms using common denominator in the denominator. Okay, so let's add. It's just cross multiplying. So you have a denominator of y, common denominator. In the numerator, you will have negative 3 times 1 plus 2y times y. So plus 2y square. And then to make it into one fraction, you see the fraction in the denominator will get flipped. So y will be in the numerator. So in the end, your answer will be negative 2xy divided by negative 3 plus 2y square. Here is the derivative. Thank you.